Hello everyone, welcome back to my channel. So today we're going to start the video by solving question number 13. So this is a circle theorem question. Let's read it out. PQ and R are 3 points on circle center O. Angle POR is 124 degrees. We can see that. Calculate the size in degrees of PQR. Give reasons for each stage of your working. Alright. So, by the way I'm seeing it, I can say that a lot of students would immediately do 124 divided by 2, which says angle at the circumference will be half the angle at center, but this is not the case actually, because that gives the angle on the other side of the chord. Since Q lies on the small arc between P and R, the angle at Q is looking at the large arc. So we must find the reflex central angle first by doing 360 minus 124, which gives us 236, and we're going to divide 236 by 2 to get angle PQR, which gives us the answer 118. But a lot of people might not understand the process, so I'm going to be solving it in a different way, as this is a very classic IGCSE trap question for a lot of people. You can draw this two arcs because we know that the angle at the center is double the angle at the circumference, which would mean the angle at circumference is half the angle at the center. So let's just call this angle X. Angle PXR is 124 divided by 2, which gives us 62 degrees. Okay, so we already found the value of this angle. Now if you look closely, the diagram has become like this now. It's like a cyclic quadrilateral. Let's just name the angles X, P, R, Q. Now since we know this angle is 62 degree, we have to find this angle. We can now easily do it, as we know that opposite angles in a cyclic quadrilateral add up to 180 degree. So to do that, we can just simply do 62 plus angle Q equals to 180 degree. That will mean angle Q equals to 180 minus 62. That will give us the answer, this 118 degree, which is the answer for the angle they told us to find. Or you can just write the entire thing. They said angle PQR, right? So PQR. There we go. This is the answer. I think this step is more understandable. Oh, I forgot the important part. They said to give reason for each stage of your working. So let's say this is the first step and this is the second step. So the first step would be angle at the circumference is half the angle at center. Step 2 would be opposite angles in a cyclic quadrilateral add up to 180. Okay, so this is the next question. Let's read it out. The diagram shows a square ABCD. M is the midpoint of AD, N is the midpoint of AB. Prove that DAN is congruent to CDM. Both are triangles. Let's check which one they're talking about. So they said triangle DAN. So DAN. Okay, this is a triangle. Then they say CDM. So CDM. Perfect. So based on the questions, we have to identify the triangles and compare the corresponding sides. With our first, when we look at it, we can say that DA is equal to CD, like this. It's pretty much predictable, so this is going to be our first. Prove DA DA is equal to CD. Second, so we know that N is the midpoint of AB, so AN will be half AB. Am I right? In the same way, we know that M is the midpoint of AD, so DM would be half AB. Sorry, AD. These are bullet points, by the way, using bullet points. So we can tell, let's just write here, so AB equal AD, therefore AN equals DM. This is a 90 degree and this is also a 90 degree. AB is perpendicular to AD and CD is perpendicular to AD. So angle DAN is 90 degree, which means angle DAN equals to angle CDM. Perfect. Now we have to do the last congruency test. We're going to state it. So we have shown that DA equals to CD, AN equals to DM, then angle A equals to angle D. The angle is between the two equal sides, as we can see over here. So this will be a side angle side. Side angle side. This question is pretty easy. I think this is the final statement. This literally like strengthens your entire proof. Okay, I would like to improve something. Improve questions. Don't start by guessing the congruency rule. First, hunt for two equal sides and one equal side, or whatever combination fits. Then decide whether it is SSS, SAS, RHS, or ASA. That's the habit most examiners want to see. So we're done. Let's move on to the next question.